Okay, now these next few examples have to do with simplifying radicals, ones that have a lots of stuff going on the inside. So let's look at how we can do that. I have a square root and a cube root to look at here. Let's start out with this one, the square root of 124, r to the 6th and s to the 5th. Okay, the first thing you want to do is look at the number 124 and do all the prime factors of 124. It might be helpful to recall what a prime number is. Prime numbers start at 2 and have numbers like 3, 5, 7, 11, 13, and so on. They're all numbers that only divide by 1 and itself. So we want to try to divide out all the prime factors of 124. We always start with the smallest prime number and see if it'll divide. In this case, 2 does divide into 124 62 times. And then we keep dividing by 2 as long as we can. And when we can't, we'll either have completely divided out all the prime numbers, or we'll go up to the next number and try to divide it into it. So we did 2, and we'll try 2 again. 2 does divide into 62 31 times. Now we're at 31. Can you find any other numbers that divide into 31? In this case, you can't. 31 itself only divides by itself in 1. It's another prime number. So once we've factored out all the prime numbers we can, we've written out all the prime factors, and what we'll do is we'll go over to our square root, we'll put our prime factors inside, 2 times 2 times 31, and now, since we have 6 r to the 6th, I'm going to list out r times itself 6 times, 6 r's. S to the 5th can be written out as 5 s's. And now what we do is we circle groups inside of the square root. And for square roots, we circle groups of 2, 2 at a time. So here's a group that we can circle, and then we have a couple of r's here, here, and here we can circle. And then we have a couple groups of s's we can circle. Okay, and now what we're going to do is we're going to bring out for each one of our groups one of the things that we've circled. So I've circled this group of 2's, I get to bring out 1, 2. I circled this group of r's, I can bring out an r, another group, another r, a third group, a third r. So each group is a single r, and each group here would be a single s. So 2 groups of s's, 2 s's. That comes on the outside of the square root, and then on the inside, left over is 31 and s. Okay, and then what we'll do is bring this all back together, 2, and then we have r times r, that's r to the 3rd, s to the 2nd power, and the square root of 31s. Okay, so that's the idea. Prime factors, breaking it down, and then write all the variables out and then circle in groups of 2. Let's look at this next one, where we have the cube root of 135, a to the 6th, b to the 5th. And if you'd like to follow along, go ahead, pause the video here and start off with this question. We'll do the prime factors again for 135. We'll start off dividing by 2. Does 2 divide into 135? Well, in this case, 2 doesn't divide into 135. So we're going to have to go up to the next number, 3, and see if it'll divide. And indeed, 3 will divide 45 times. And now we'll see, does 3 divide into 45? It does divide in there 15 times. And 3 divides 15 5 times. And now we've worked our way all the way down to 5, and that's as far as we can go. So these are our prime factors of 135. So now I'm going to write out the cube root. I'm going to put 3 times 3 times 3 times 5, and then 6 a's and 5 b's. And now, since we have a cube root instead of a square root, the difference is the groups that we circle will be groups of 3 rather than groups of 2. So it looks like I can circle a group here of 3's, I can circle 2 groups of a's, and I can circle 1 group of b. And then bring each of those out as a single one of each of the things. So we get 1, 3, 2 groups of a's, so 2 a's, 1 group of b, so 1 b. And then on the inside of the cube root would be 5 and b times b left over. So when we put this all back together, that would be 3a squared b and the cube root of 5b squared. And that'll be our final simplified answer for this one.